Thanks for joining me at the workbench of 4111 Spyglass. Over the past weeks, we looked at the CC1101 radio boards, namely the blue board operating in the 433 MHz band. These boards are cheap and readily available from the usual sources. However, there is also a green board operating in the 915 MHz band. Since 915 MHz is in the open ISM band here in the US, I decided to give it a try and to compare it against the blue board. The blue board is labeled 433 MHz, but many vendors advertise 315, 433, 868 and 915 MHz functionality. Being able to operate in all these bands seems unlikely, as the chip manufacturer, Texas Instruments, provides two different schematics in the datasheet. One schematic is for operating with carrier frequencies in the 315 and 433 MHz bands. The other schematic is for operation in the 868 and 915 MHz bands. The components near the chips are all the same. However, on the RF sides, the balloons and the filters, they are very different. So given these schematics, I find it highly unlikely that the blue boards would operate across all these bands. The green board is only advertised as 915 MHz. The website does not mention any other bands. Just from the picture, both boards have the same size, same mounting holes and the same pinouts. We later discovered, however, that the green board has a pinout with a 5x2 connection, while the blue board has a 4x2 connection. The mounting holes are also different. The green board has 4, the blue boards have only 2 mounting holes. Despite their apparent similarity, the two boards are quite different. Previously, we already showed that the blue board operates at 433 MHz, so there is no need to demonstrate that again. Let's try 315 MHz instead. The software-defined radio waterfall demonstrates that the blue board works nicely on 315 MHz. Let's try the blue board at 868 MHz. As we suspected from the schematic, we don't see any packets on the waterfall. I won't show 915 MHz, the waterfall is empty too. Let's try the green board at the advertised 915 MHz. Unsurprisingly, we see packets flowing down the waterfall. If you look carefully, you may notice that the spectral peaks are smaller than we have seen before with the blue boards. Just for diligence, let's try the green board on 315 MHz. Given the two schematics in the datasheet, we don't expect anything. What is this? Why do we see packets being transmitted by the green board at 315 MHz? If you look closely at the spectrum, you may even notice that the peaks are higher than for 915 MHz. Not quite what I expected to see. A more systematic analysis shows the blue board operates best around the advertised 433 MHz. We get about -40 dBms across my workbench at reduced power levels. At 315 MHz, we get not quite as much signal. And we have no signal at all at 868 or 915 MHz. From the green board at 915 MHz, we get less than -90 dBms across the workbench at the same reduced power levels. 868 MHz shows a few dBms more, while 433 MHz is comparable to the target 915 MHz. The big surprise is 315 MHz with -80 dBms. Just briefly looking at the link quality index shows that the blue board has higher LQIs than the green board. We need to take these numbers with a grain of salt. I'm testing both boards with the antennas provided by the sellers. These antennas are tiny compared to the wavelength. We are testing with 5 cm antennas when the wavelengths are 30 and 70 cm. The standing wave ratio will be huge unless the antennas are carefully tuned for one frequency. Comments on the internet clearly indicate that the antennas are badly tuned. So let me give you my opinion on blue versus green. The blue boards operate well at the promised 433 MHz. They're readily available and cheap. They can be gotten for just a couple of dollars. They do operate at 315 MHz, but they do not work at all at 915 MHz. The green boards do work at the advertised 915 MHz, but not as well as the blue boards do at their advertised 433 MHz. Surprisingly, they do seem to work best at 315 MHz. The green boards are difficult to get. I found only one seller. Not surprisingly, they're nearly $20, and then there is shipping and tariffs. Last but not least, they are not a drop-in 915 MHz substitute for blue boards, because the green board uses 5x2 headers, while the blue board uses 4x2 headers. So given price, availability and the signal strength, I declare the blue board the winner of this matchup, even if the 433 MHz band is not open for unlicensed use in the US. Thanks for watching. See you next week.